Thank you everyone for showing up. My name is Joel Racinos. I'm with Precision Property Measurements, and with me will be Alex and Greg. They'll be co-presenting this presentation. As I mentioned before, please put your first and last name, your email address, and your AIA number so that we can get you the credit for this course at the end of the presentation. And stay tuned for our raffle at the end. And if you have any questions, feel free to throw them in the chat. We'll either answer them here on the spot or we'll reach out to you later on if they're a little bit more in depth. But again, thank you so much for your time. And now I will pass it off to Alex and I'll just be admitting people on the side.
Awesome. Well, thanks, Joel and Merlin for organizing this and getting this ready. Hello, everyone. I'm glad that you could join us for our second AIA webinar on as-builts. For those of you that are joining us for the very first time, welcome. And I'm happy you could join us today. And I hope by the end of today, you learned something new to improve on your current as-built processes. And if it's your second time joining us, I'm glad to have you back. I hope you find this experience even more enjoyable and beneficial. Now, before we start, I'll just go ahead and introduce myself. My name is Alexandra Pham. I'm the Regional Director for the Miami office, and also presenting with me today, like Joel said, is my colleague, Greg Davis, who is the Director for Special Operations. PPM has been servicing architects and designers all over the country, reliable as-built surveys for over 2 decades. And as time has passed, the way we gather our on-site data has evolved and undergone a lot of changes. In this presentation, we'll walk you through the methods of our data collection and how we draft our as-built plans. Now, before we go any further, here's the course description and your learning objectives for this course. At the end of this course, you'll be able to create as-built plans for any project type. You recognize the various laser scanning technologies used for data collection. You would understand the role that point clouds plays in displaying your data in a usable form. And finally, you become more familiar with the techniques for drafting and modeling as-built plans in Revit or AutoCAD. So we do have 3 main topics we'll run through today. The first being what are as-built plans. Then we'll touch a little bit about the 2 processes of collecting and gathering your on-site data. And finally, we'll run through how you could create your as-built sets in AutoCAD or Revit. Now, what are as-built plans? In simpler terms, as-built plans are just drawings or models that accurately represent the existing dimensions and conditions of a building. Now, before we go any deeper into this presentation, I would like to mention that today we'll only focus on production of as-built plans in 3D Revit model or 2D CAD files. However, it's very important to know that there are other softwares out there that you could use to develop your as-built plans. All right, before we start with our first content for today, I would pause here for a quick poll. Just feel free to have your comments or your answers in the, just type your comments and answers in the comment chat below. The question is, how do you currently create your own as-built sets? A, I create them myself. B, I have an internal team. And C, I partner with an as-built professional. Just give you a second to do that. So collecting your on-site data. Now, before we go into collecting this, I'd like to mention that we do have 2 main processes for doing this. The first being the traditional process, which I'm sure you're all familiar with. This involves taking pictures, sketching, and then we have the more advanced method, which involves using your laser scanners. When you're scanning the project, processing that data is a very crucial part of the on-site activities. Traditional methods. The traditional method, like I said, is basically just sketching, and I'm sure you're all familiar with sketching, so I'll keep this simple and brief. Just remember that sketching does not need to be to scale. You just want to make sure you have enough room on that paper to take down your dimensions and some important notes. Get all your sketching done before you start taking dimensions. This process is very important so that you can take your dimensions quicker, and it's also important for you when you're taking your running dimensions. Now, on the plan view, the best way to start taking your dimensions is to start measuring your exterior faces. When taking these dimensions, you want to make sure to check that all your X and Y axis dimensions match. This, of course, can be a little bit tricky and complicated if your structure is a bit curved or you have walls that are not at 90 degrees. Next, you do want to save time. You can save time by using tracing paper to take down your different dimensions. And just as you can see on the image on the screen, you can simply add more information or symbols using your different color pens. For this process, I would highly recommend you get one of those sketch pads that come with vellum, so then you don't have to carry multiple items on site, especially if the site you're working on is a little bit more complicated or, just not pretty. And with that being said, this concludes our traditional methods of surveying. I'm going to pass it over to Greg now, who would run us through the advanced method using your scanner to collect data.
Awesome.
All right, Greg.
Thanks, Alex. Yeah, that all brings me back to the good old days of as-builts. Quick introduction. I've been performing as-built surveys for 22 years. I've been with PPM for 7 years, and I led the effort here to bring laser scanning to our as-built workflow. So one thing that I definitely learned the hard way is that updating and replacing a proven traditional method for something to utilize the newest technology is not easy, and that's no matter what industry you're in. But the first step you take is the most important, and the rest is hard work and diligence. Even though it may be difficult to transition, making the change to laser scanning as a survey method for as-builts provides you with fast data acquisition, more accurate measurements than any measurements that can be taken by hand. It really reduces the odds of human error dramatically in the field. It's a thorough solution, allowing us to gather more data than we need to complete most projects. And it gives us a digital twin to pull additional data down the line if our projects ever need to be revisited, or if there are additions that need to be made to our as-built scope of work. Okay, so what does LiDAR mean? We hear about it in the news, in articles about autonomous vehicles and robots, and it's the same technology we use to get survey data. Well, it stems from the word radar, which stands for radio detection and ranging. That's a much older technology, but it works in the same way. So LiDAR is a method for measuring distances by illuminating an object with a laser and measuring that laser beam's reflection with a sensor. Each single measurement is logged, and throughout the course of the scan, millions and sometimes even billions of measurements are taken in all directions. So let's talk about some LiDAR scanners currently used for architecture, engineering, and construction. When we need very accurate measurements or a lot of intricate detail captured for historical projects, structural or engineering analysis, or prefabrication projects, we go to this scanner, which is our favorite, the Leica RTC 360. Even though this needs to be set up on a tripod, the individual scan times for the RTC 360 are relatively short compared to other terrestrial scanners, making it the fastest terrestrial option out there. The iPad also helps make sure you can check your point clouds, that's the resulting data you get from the laser scanner, before leaving the job site. This scanner is extremely precise and gathers so much data that the point cloud files can be over 500 gigabytes. Whether we use the onboard camera to make a color point cloud or not, we always get very dense and very accurate data that allows us to draft and model ornamental detail, pipe valves, and other intricate details with precision. Because our final data is made up of hundreds or even thousands of scans performed with this scanner, it makes it ideal for starting and stopping, which is sometimes required in busy spaces like hotels, shopping malls, and industrial spaces. So in the next slide, we'll see a short video of a point cloud that was generated using this scanner. So while our other scanners can be moved while they are operating, as I mentioned, the RTC 360 needs to be placed in multiple positions all over the building to get a full set of measurements for our plans. Each red dot you see here is a place where we strategically positioned the scanner to gather black and white data you see here. Even though we did not use the camera for this data, you can see how much detail we can get using the black and white measurements gathered. Each black and white point or pixel is a representation of an actual laser measurement, accurate down to less than 2 millimeters. This means that the entire 3D picture you're looking at is dimensionally accurate. We used this data to help an architect identify floor sagging, wall sagging, and other structural issues before a major remodel of this 100-year-old casino in Colorado.
Okay. Very good.
So this next slide shows a Revit model that we were able to generate using data from the RTC 360. This is the Marin Veterans Auditorium in Marin County, a building designed by Frank Lloyd Wright, but built by Taliesin West after his death. Our surveyor spent approximately 74 hours over 7 days at this site and scanned every single room and interstitial space, including subfloors, above ceiling lofts across the 55,000 square foot auditorium. In the next slide, we see the interior of this auditorium. It took our modeling team a combined total of 304 hours to model every single architectural, structural, and almost every mechanical feature in the building, including all mechanical piping 2 inches in diameter and greater throughout the entire building. The client needed this accurate model and scanning to be able to update all of the structural footings and slab that are currently at risk due to erosion and water damage. As part of this, they also expect to make a large upgrade to their mechanical systems as well, both for the building itself and theatrical devices in the space. So just another example of what that Leica RTC 360 can bring in terms of precision to large, complicated projects like this. And with that, I'll hand it back over to you, Alex, to tell all of you more about our super fast mobile scanners.
Awesome. All right, mobile scanners. They're handheld and very easy to use. We have 2 types of mobile scanners, which we'll discuss shortly. You want to use a mobile scanner, preferably if you need accuracy and your time on site is limited. And since most of the individual scans only take about 15 to 45 minutes, we recommend that you scan and you process your scans on site before you leave, so you could, look at the results. And once the scan is complete, you need to use the SLAM algorithm software, which then interprets all the measurements and movement data from the scanner to produce the 3D point cloud. After the 3D point cloud has been created, then you need to review that point cloud data to ensure accuracy. Most errors that do occur when scanning can be spotted quickly, as you would see in the coming slides, and actions such as rescanning can be taken to ensure your overall project accuracy. This is what your point cloud data looks like in plan view. You can see that even though there's no photo-based colorization of the points, these points are colored on a height ramp, where the points at the different heights are shown as different colors on the spectrum, as you can see on the left side of that image. The red is the lower heights, and then you go into the blue and the cyan representing the higher heights. Coloring the points this way makes it easier to see important features in the point cloud, even without a photo colorization. All right, we said there are 2 scanners. This is the mobile scanner. It's one of my favorite. This scanner does reduce your time spent on site by 90%. It collects over like 300,000 points per second with a 6mm accuracy. It also covers a range of 100 meters, and you can scan up to 50,000 square feet of space in just hours. With this scanner, you can scan pretty much anything. It has to be visible, of course. We've used it to scan single-family residentials. We've done commercial spaces, retail spaces, warehouses, and actually more recently, we did scan for rehabilitation process for the Apollo mural restoration in South Beach. So for those of you from South Beach, you're probably familiar with that particular mural. So yeah, like I said, pretty much anything. It just has to be within the scope of that scanner range. This is a very expensive tool, so you want to be very cautious when you're using it on site. Here is an example of a project we scanned using the Horizon mobile scanner. This is a 9,000 square foot single family residential house located in Washington, DC. This beautiful property was built in 1836 DC, and as you can imagine, there were no as-built plans to reference. So the client requested our remodel package, which includes a floor plan, roof plan, exterior elevations, and still photos. This project was modeled in ArchiCAD, and it took our team about 36 hours to completely draft it from the point cloud data. The total time spent on site to survey this property was 6 hours. So just imagine how long and difficult it would have been if you were using just the traditional method we discussed earlier. Here is the second mobile scanner. Just like the mobile, the Horizon, we just did, the Revo scanner is also handheld. It's just slightly smaller in size than the Horizon. It also reduces the scanning time by 90%. This scanner collects 43,000 points per second with a 6mm accuracy. Again, you can scan just about anything using this scanner. The only thing to note is that the Revo scanner collects fewer points than the Horizon. So for larger projects, you may need to merge more cloud data. Again, you can scan up to 50,000 square foot of space in hours. Of course, you have to consider the construction type and the density of that project. Here is an example of a mixed-use project we scanned using the Revo. This is a 27,000 square foot building located in Seattle. The client requested floor plans, roof plans, exterior elevations, reflected ceiling plans, and interior elevations. This image is just showing what the RCP ended up looking like. And as you can tell, it was a very dense project. It took our team about 8 hours to scan and 36.5 hours to draft the project in AutoCAD. Now that we have explored the tools used for the advanced method of data collection, let's take a quick look at the point cloud data. Here. After processing your scans, you want to check that on site, but you also want to check that before you start drafting. You need to do this and review the point cloud data just to ensure that all areas were covered during the scan and that you have no flaws such as drifting or any other errors that may occur. Here's a good example of what drifting looks like. In this photo, you can see where that wall shifted. This occurs for multiple reasons. So it's very important that you decide or determine what went wrong before you attempt on reprocessing the data or rescanning the project. Drifting includes reflection noises, other data noises, large buildings, internal scanner errors, and duplicate data. So it's very important to know exactly what it is before you then know exactly what you want to do next. One last thing, since the scanner has such a wide range, you want to make sure you trim or you crop your point clouds to eliminate any excess data from your long-range scanners. For the larger projects, you would need a point cloud software to merge and streamline the point cloud data. And just like the traditional method, with much practice, it becomes easier to recognize a bad scan, and you also get better at preparing ahead of time to minimize errors during a scan. Now that we've collected the data using the methods we discussed earlier, it's important that we now explore the next part, which is our final part for today, the actual creation of this as-built sets. But before we go further, and I'll probably pass it on to Greg at that point to explore that, I would like to pause here so that we can take our second poll for the day. All right, again, just write your comments, your answers in the comments tab. What softwares are you currently working on in your companies? Are you using AutoCAD? A, I plan to always use that and work in AutoCAD. B, being AutoCAD, I'm interested in working with other softwares. C, Revit. D, ArchiCAD. And E, SketchUp. Just a quick note here, for those of you that are going to probably select Revit, can you just write the year of the Revit that you're also referencing or using in your offices? Just give you a second.
And Alex, we'll stay here for about a minute and I'll monitor the chat for you.
All right, no problem. I think same thing too with ArchiCAD. It doesn't really matter, but Revit especially. How are we doing?
Yeah, doing good. Great. Thanks for the responses, everyone. Go ahead, Alex. Sorry about that.
All right, thanks, guys. All right, Greg.
All right. Really neat to see Rhino in the chat. I'm gonna have some questions for you later, that's for sure. So yeah, let's talk about drafting from the point cloud. Thanks, Alex.
Okay.
So when drafting from a point cloud, the first thing you'll need to do is get into a drawing environment, which we just talked about a few of those in that poll. So you can import directly into AutoCAD or Revit, as well as other architectural software. If you do use Autodesk products, there is an application called Recap, and you need that to be able to prepare or convert that point cloud format to ensure that it works within AutoCAD and Revit and anything else that's made by Autodesk. Drafting from a point cloud in CAD is pretty straightforward, but it does take getting used to. So there's lots of options in CAD to color, slice, crop, move, and rotate the cloud in different ways. And you'll need to use the view cube regularly to adjust your UCS orientation to work with the cloud in different positions. That said, point clouds are ideal as-built data sets for creating Revit models. Unfortunately, the Revit point cloud tools can feel a little bit lacking. If you're making a 3D model, it only makes sense to work from a 3D point cloud to create an accurate model to kick off your designs and planning. The tools for visualizing the point cloud are not as robust as they are in AutoCAD, which is weird because it's a 3D program, but nevertheless, point clouds and Revit go hand in hand.
Awesome.
So in the image here is an example of a slice of a point cloud in plan view. Regardless of how you get your survey measurements, it's good to start any as-built by starting with a floor plan. When drafting in CAD from a point cloud, you'll want to ensure that your cloud is positioned orthogonally. So you can use the ortho function in CAD to easily draw straight and perpendicular lines. If you're going to work on elevations or need to extract any heights from the point cloud, it's also good to position the point cloud in the Z-axis. Typically, we start by lining up the finished floor surface of the first floor at 0, 0. Once you have the point cloud well positioned to begin drafting, you should be able to derive all of the walls, doors, door swings, and any other visible architectural and structural information right from the point clouds. Some scanners will not pick up smaller items, especially if they are flush with the walls or the ceilings. Trying to locate them in the cloud can be very time consuming. So often we find it better to use the more traditional measurement tools while in the field to sketch and measure things like electrical items on the walls. Okay, so let's get into drafting other views such as elevation from the cloud and sections. When working in a 2D drafting environment, it's important, it's not only important to have your point cloud well oriented in the drafting space, but you'll need to be well practiced at manipulating the coordinate system views and the point cloud sections. Once you do, you will see this is where there's a huge advantage to having a complete point cloud for drafting. Provided that you were able to access the roof in scanning, you will have a complete picture of not only the roof behavior, but also every height you'll need to properly draft your roof, exterior elevations, and any section that you might need. As with electrical and RCP components, sometimes it's beneficial to revert to the traditional methods to sketch elevation ornamentation items that you'd like to include in your drafting. Okay, so we talked a little bit about AutoCAD and drafting in AutoCAD, but let's see how this works in Revit. So first things first, I want to talk about something that's very important to us here at PPM regarding Revit, and that's the level of development. This system was created for the AEC community to put standards on BIM models. It describes the different ways in which 3D objects can represent existing or design elements in a BIM model, with level 100 being the lowest, meaning that you just mass your objects roughly, and level 500, the highest, being so detailed and exact, you are essentially building a virtual version of the structure. Every nut, every bolt, every washer, everything. When modeling as-built plans, LOD 200 is the most applicable level of development. During the as-built scanning, we are assessing a structure that has been built from the outside. And with many of the interstitial spaces being inaccessible, the specific construction of many architectural and structural elements cannot be determined, which is what is required for higher levels like LOD 300 and above. So just wanted to get that out of the way real quick. Let's talk a little bit about modeling from a point cloud. So similar to drafting in AutoCAD, the first thing you need to do to work with a point cloud in Revit is to make sure that you have it in the recap format so you can use it with Autodesk products like Revit. Then using the point cloud to guide modeling in 3D, it can be a little more complex than drafting in 2D. However, the benefits of having all elements of a building related to each other in a set of 3D drawings can be valuable to your design and planning process because you can see the way things interact with each other in a way you can't see in a set of 2D drawings. So viewing this point cloud and model in 3D provides even more information about how structure, MEP systems, and architecture all interact, far more than you would find with just a 3D model alone. Modeling an as-built in Revit may seem overwhelming at first, but a solid order of operations for creating usable Revit models will go a long way. So let's talk about a few things you need to do before starting your modeling to make sure you can put the best foot forward. So first, let's talk about modeling the plan view items from a cloud in Revit. When modeling in Revit from a point cloud, you'll want to ensure that your cloud is positioned orthogonally, just like in AutoCAD, so that you can use the ortho functions to easily place walls. Then, much like we do in AutoCAD, we set the finished floor of the first level to 0, 0, and then we create and set all other levels in Revit to key features in the point cloud, whether that's other levels or plenum or top of roof, etc. Once you're done setting the finished floor, you can start adjusting your view range in plan view and view depths to start adding your walls and your doors and your window families in the places indicated by the point cloud. So as with AutoCAD, this is where there's a huge advantage in having a complete point cloud for modeling. Drawing sections and adjusting section depth is crucial to viewing point clouds effectively when adding and adjusting window heights, door heights, creating roofs, and other elements in your model. It's very, very, very important as you're running through this process and using a point cloud to model a Revit model to practice patience. Roofs in particular, particularly residential roofs, are very tough to model. But even more so when you want to make sure you're matching them as accurately as possible to a point cloud to get those slopes and curves and things just right. So that's it from me on some of the technical aspects of drafting and 3D modeling from the point cloud. Alex, back to you.
All right, there are some advantages to having a BIM as-built, some of which you may already know. Sometimes a 3D dimensional model is only considered for presentation for design purposes, but it can also be useful as an as-built as well. All right. Now we're about to take our last poll. What is the most important factor for you when you're generating your as-built plans? A being the quality and assurance, B being timeliness and turnaround time, C, efficiency, and D, cost. Do I need to pause for this a little bit, Joel?
Yeah, let's pause here, and I'll take a moment to remind everyone, since we had some people join mid-presentation, to leave your name, your email, your AIA member number, and your license number so that we can get you credit for this course after we've finished up. We'll wait here while I monitor the chat for you.
Okay. All right, I think the next we're going to go into Q&A. We're almost going into time.
Oh, hold on, Alex. Let's
Okay.
Yep.
Just the region. Take all the vowels out. Take all the vowels. It's like yeah. 8.
All right. Thanks, Alex. I think we're good to go to the next part.
Thanks, Joel. So I do have a question for all of you. How often do you require as-built plans before starting a project? Again, you can just, probably at this point, we could talk back and forth. This is our Q&A session. And also, I want to understand what is the most challenging part of developing your as-built plans, assuming you're doing it yourself. That's my question for the team. Feel free if you want to comment or say anything. And if you have any questions for what we've presented, what is about the laser technology, that's the advanced methods or the traditional methods, or just any question in general at all. You can send your questions in to Joel on the chat, or you can just request and I will pass on I think we can unmute you to ask the questions.
Yeah, I'll be happy to answer any question or relay any questions if you guys have some.
Mhm. Can't see the comments. No questions. Yeah, it looks like we did a good job then covering all the topics, and you're able to understand everything.
About this Rhino, is that I'm a little bit unfamiliar with that. Is that a software that you guys use?
Okay. I think that's a question for Greg regarding Rhino. I'm not particular.
Yeah,
sure.
we don't use Rhino, and I was just also chatting there, just saying that's the first that we've heard that actually, that someone uses Rhino entirely for as-builts and for just for full architectural modeling. I have heard of using Rhino for modeling more organic elements, you know, like very dense and intricate ornamental items that are near impossible to model in Revit. I've heard of people modeling those kinds of things in Rhino, then exporting those models and bringing those into Revit to be able to more easily show those kinds of things. But that's really cool. Yeah.
Oh, nice.
Cool to hear. Don't worry about it. You didn't cause a stir. It was super interesting. Thanks for sharing.
Yeah, while we're waiting for some more questions, again, remember to write down your name, your AIA number, so that we can give you credit for this course later on. Still see some trickling in as we go along.
Do we have anyone that's joining us for the second time, or is this all your first time joining us for this presentation? Just curious. No?
Yeah, or if you're like, not longer than short hair or like whatever, like.
First time. Well, nice to have you, Edgar. Oh, thank you, Michael. Thank you for coming. Thanks. I hope you learned something new. And if you need anything else, you could just always message us and send us your questions.
If anyone has any questions about the laser scanning technology, please let us know. We'd love to answer them for you and help you understand those things better. Help determine if maybe they're a tool for your firm, for your team.
Chloe, Marilyn is in the chat, so we can link up with her later. But be sure to leave everyone leave your email in the chat so that we can send you the course. So that you oh, and also there's going to be a raffle too. So yeah, be sure to get all your information in the chat so that we can answer any questions afterwards.
Okay, I think Edgar has a question. Is there a resource video we can use for a presentation? I think Joel already talked about having our YouTube.
Yeah, so after the presentation, because it's all recorded, so we're gonna post it to our YouTube, and if you leave your email in the chat, we can send it to you afterwards if you would like it.
Okay. Another question, has any of you ever used a professional to do your as-built plans, and were they using laser scanners, or have you yourself used laser scanners to do your as-built drawings? Just curious.
There'll be they're kind of changed. I should
Okay.
get these remade. Yeah. And like give them to like my cousins and like give them to
Oh, nice, Michael. Good to know. So you're kind of familiar with the process already.
You have access. Getting that exact same app.
Do you guys see any benefits with hiring a professional or using a laser scanner versus a traditional method? Or do you have any concerns about either of the processes and maybe what you prefer to use? Kind of weird. I think more of the emails are coming in instead. All right, is this safe to assume there are no questions then?
Yeah, if you want to show the information on the next slide, that will, I believe it's the, only people know how to contact you if they have any questions
Yes,
afterwards.
definitely. Well, thank you again for attending this webinar. I hope you were able to gain some insights, and perhaps I'll get a chance to collaborate with some of you in the future. If you're interested in learning more about the laser technology and how it can be useful for your as-built practices, we offer lunch and learns to audit your current as-built processes and see how PPM can help you improve on them. So please, if you're interested, feel free to comment in the chat below and or send me an email afterwards. And yeah, always glad to help you start your project correctly with the accurate plans, and whatever we can do to make you look good before your own clients, we're here for that too. So feel free to reach out.